especially if you have small data. It's just simple. I just want to go on showing how simple. If you have a revision 1 file, if it's a good revision 1, you just select it. Don't want to see anything. Next. It is 100% revision 1. Nothing to be done. Oh, look, it's a cube. It can't be a cube. Let's see. Ah, that's not very nice. I forgot to make that pre-stack volume. Go again. And now you see that we have this other identifier, which is offsets, maybe azimuths. They can be either in the file or they can be calculated. If they're calculated, I have to make sure that these these standard seg-y fields are actually filled. If they're not present, you can at least have them generate, but then you have to have regular. So the offsets, just must be a constant number of offsets per position. Here, of course, it says it should be offset, and the byte is standard 37. If it's not 37, it's not standard, but you can still overrule it. We don't have azimuths. We don't have to do anything else. And we have the data store, yeah, but, well, pre-stack data store. But you may have multiple types of migration or whatever. Okay, what now? We don't have a post-stack volume, we just have pre-stack. It is loaded because we can see it in Manage Seismics. Bang, you can see, inline range, crossline range, everything looks okay. Well, why not just pop up an inline and then right click on it. And there you see, display pre-stack data. Pre-stack data store. And there we are. This is our pre-stack data, so we can position it and we can see it changing. There's actually, it's gone on my other screen, but you can actually control it with this little thingy here. And to conclude this, I could say you could also do something. Well, no, it's not concluded. I can actually do something else. I can even have a stored cube. It has now made for me a stored cube, which is based on the pre-stack data store. But these curly brackets show me that it's not really a normal cube. But anyway, if I click on it, and this is all 4.2, I think, you can select an offset to look at it. So let's take the far offset. And well, this is then the far offset. I can do everything with that I can do with an ordinary cube. Another thing is to start stacking the data. Why not? That's in the attribute set. There's an attribute called pre-stack, which basically does all kinds of things with your pre-stack data store. You can, for example, pre-process. Well, I don't have one ready, where you can do all kinds of stuff. You can, well, I don't want to pre-process. You can do an average or a median stack or RMS stack. Let's just make a median stack. It's fun. It's not usually done, and then I say it's called median. Add as new, just the way you normally use attributes. And I can add this as an attribute, or I could replace it. Oh, sorry. I wanted, of course, the median, and this gives something else. The fact that it's a bit brown, it's basically because what you can see is that the color scale is a bit asymmetric. You can force that. You can force to say, no, I want to auto-detect symmetry. Yes. And now you can see it's not brown anymore. So there's all kinds of things, but that basically concludes what I wanted to say. I don't think there's a lot more. I think I've now more or less shown that you can load difficult seg-y files, but you have to learn a little bit more about the context of everything. And the easy ones, the revision 1 files, they are easy to load. I'm convinced that that should not be a problem as long as you have good revision 1 files. So that would conclude it, and I would then like to give the control back to René.
All right, well, thank you very much, Bert. We have had a few questions come through in the questions pane, and one thing that I would like to go ahead and point out to everybody is look for your questions pane, because a response has been sent to everybody that is providing you the link where you can find the description for all the documentation going along with the SegWire Revision 1. So please make sure that you see that. If not, you can send me a question or a message, and I'll try and get that passed along to you. And now, if you would like to ask Bert a question, then please raise your hand or type it into the questions pane. And while you're doing that, I will go ahead and give you a little bit of information. This Friday we'll be sending out an email with the recorded version of this webinar. It will also have a feedback form in there, so you can fill that out, and we'll also try to combine it with a bunch of other information, so you're not going to be bogged down with a whole bunch of emails. We'll send out some information regarding the upcoming SEG that will be in Denver next month, or actually in 2 weeks. And I'm going to make a little plug for that real quick. We have a few things going on at the SEG. We're going to have a users meeting the Sunday that the SEG starts, and the Friday and Saturday before we'll be holding introduction training and advanced topic training. And also throughout the SEG meeting we'll be holding a Meet the Detector arrangement where you can come to our booth and either sit down with some data or just sit down and ask some questions. So you can email us at support-americas@dgbes.com. So you can schedule that setup. And also we will be giving away a few Kindles with the promotion we're doing. So stop by our booth if you are at the SEG. And now we do seem to have a question ready to go. And also I'd like to advertise that next month we're going to be having the next webinar on November 3rd. It will be basically what should one think of when doing a colored inversion. We'll be talking about seismic colored inversion and seismic spectral bluing, and this will be hosted by Arnaud Hoek. So please tune into that. And now the question that I have here is, tell us about SegWire format and byte swapped. So if you can field that.
Okay. Let's look at it again. So one of the problems of the original revision 0 standard was that it wasn't really clear how to there were actually two systems in the world, more or less. Let's say there were the how am I going to say that without real computer gibberish? There were computers based on a certain way of storing numbers in memory, and there were other computers which were stored the other way around. So we had the big and the little endian machines, and people on a big endian machine had, they had this tendency to put things in big endian, also in files, and little endian, which is basically what PCs are. They did it the other way around. Now the problem is, if you get such a file, you'll have to basically swap the bytes before they are going to be interpreted by our system. So how do you know this, when this has happened? So then you have to do, normally you have no problem. Revision 1 says clearly it has to be like this, no problem. But still there are, files out there that are completely revision 1, but still they are writing it in the wrong byte order, because that's the problem with that. SegWire is such a difficult standard that just not reading one line right can screw up the whole result. Still, how do you recognize that? Well, I'll just show you by just swapping, just interpreting one of these things as if it's swapped, and that's what you would get. And then we'll get next. Well, this looks much too good to me. Let's see whether I can do it. Oh, well, for some reason it was a pre-stake following. Dismiss this one. Next. No, for some reason I can't even get it working. Why doesn't it do that? The thing is that what you get is complete gibberish almost everywhere. The text is good. If the text, by the way, can also be wrong, because even this is clearly described in the standard that it should start with C0 and then 01, C. So the first character of every SegWi file should be a capital C. That's clear, even in the revision 0 standard. That has to be like that. Only there are two ways of encoding. Again, two ways of encoding that. There's the ASCII and the EBCDIC. In revision 0, it was clear it had to be EBCDIC. It had to be in a way that is no longer normal to encode things. Then people just started to make it ASCII because they didn't bother to program EBCDIC coding. And at a certain point, people had a trick like, okay, if it's a capital C, that I can read immediately, then it's ASCII, and if it's a C in EBCDIC, then obviously this is EBCDIC. In that way, we also do that. So we look at whether the first character is actually capital C. If not, we say, well, it's obviously it's almost certainly this EBCDIC encoding. If it's still gibberish, then it might even be that it's neither of the two. Fortunately, it's not really necessary to read the file, but it's a bit of a pity. If, on the other hand, the byte swapping is wrong, if it's not according to the revision 1 standard, or if it's not according to your local machine, then you will see that you will get lots and lots of fields there, and they're all complete nonsense and gibberish. And if you see that, then your first try should be to say, let's presume that everything is byte swapped. Now, if this one can also be interesting, if you can see that everything's right except the data. The data looks like done, whatever you would call it, then only data would be. So this is basically a tool to adapt to things that are really not good. SegWi files that are wrong, but we have a medicine for it. Same here. If the format is just simply set wrong, for example, there are still things out there that say that 6. Format 6 is simply not defined in the new standard. But at a certain point, people thought it might have become 6, blah, blah, blah. So what you can say is, well, I know, maybe from the text editor, that it is actually this one. I'm going to overrule this, just like we could overrule the number of samples. So that's why this block is there. This block is there, basically, because otherwise you can't even interpret the basic things. You can't even look at the traces because you have no clue what the number of samples is. You don't know anything. So this is what is necessary to be able to do the first examine. And then if you have that right, then you can see you can do everything with examine, etc. And then you have to specify where do I find all these things. And one thing with